What happens when you reach the edge of everything? This is a question that has puzzled scientists and philosophers for centuries. For most of human history, the edge of the universe was a realm of pure imagination. But today, astronomers use powerful telescopes and complex mathematics to explore what lies at the very limits of existence. Our journey begins about 13.8 billion years ago with the Big Bang. From a single, incredibly hot and dense point, the universe burst into existence and has been expanding in all directions ever since. In the 1930s, the astronomer Edwin Hubble made a groundbreaking discovery. He found that galaxies were moving away from each other, providing the first real evidence of this cosmic expansion. This completely changed how we see the universe. A few decades later, in 1965, Arno Penzias and Robert Wilson stumbled upon the cosmic microwave background radiation, the faint afterglow of the Big Bang itself. This discovery sealed the deal, confirming the Big Bang theory and giving us a snapshot of the early universe. So, if the universe is expanding, does it have an edge? The answer is a bit more complicated than you might think. The universe we can see, known as the observable universe, definitely has a limit. But this isn't a physical wall or barrier. Instead, it's a boundary of light and time. Since the universe is about 13.8 billion years old, light from the most distant objects has only had that much time to travel and reach us here on Earth. Anything beyond that point, what we call the cosmic horizon, is forever hidden from our view. It's like being on a ship in the middle of the ocean. You can only see to the horizon, but you know the ocean continues far beyond it. Scientists estimate that the edge of our observable universe is about 46.5 billion light-years away in every direction. Now, you might be wondering, how can it be 46.5 billion light-years away if the universe is only 13.8 billion years old? That's because space itself has been stretching and expanding while that light was traveling towards us. As the distance to an object increases, the time delay for its light to reach us also grows, until we hit that cosmic horizon. But what about the shape of the entire universe? Both the parts we can and can't see? Scientists have long debated whether the universe is finite with edges, or if it stretches on forever. The shape depends on a crucial value called the density parameter, or omega. This number compares the actual amount of matter and energy in the universe to the amount needed to keep it perfectly balanced. There are three main possibilities. A closed universe would be like the surface of a sphere finite, but with no edge. If you traveled in one direction long enough, you'd end up back where you started. An open universe would be shaped like a saddle, curving outwards and stretching on infinitely. And a flat universe would follow the familiar rules of geometry we learned in school, where parallel lines never meet, and it would also be infinite. Current evidence, especially from missions like the Wilkinson Microwave Anisotropy Probe, suggests we live in a flat universe, with an accuracy of about 0.4%. This means space likely goes on forever. Just when we thought we were getting a handle on things, a shocking discovery in 1998 turned everything on its head. By observing distant supernovas, astronomers found that the universe's expansion wasn't slowing down due to gravity, as everyone expected. It was actually speeding up. This acceleration is caused by a mysterious force called dark energy. It makes up about 68% of the universe and is pushing galaxies apart faster and faster, ultimately deciding the universe's final fate. So, what does this accelerating expansion mean for the end of everything? The most widely accepted theory is known as the heat death, or the Big Freeze. It paints a rather chilling picture. In this scenario, the universe will continue expanding and cooling until it reaches a state of perfect stillness and maximum entropy. Every star will eventually burn out, and every galaxy will drift so far apart that the night sky will become an empty, cold, and dark void. The timeline for this is mind-boggling. Stars will continue to form for the next 1 to 100 trillion years before the universe runs out of the necessary gas. The last lights to go out will be the Red Dwarf stars, which are incredibly long-lived. After them, only stellar remnants like black holes will remain, but even they won't last forever. Over unimaginable timescales, black holes will slowly evaporate through a process called Hawking radiation until nothing is left. While the Big Freeze is the frontrunner, other theories exist. One older idea is the Big Crunch, where gravity eventually wins, causing the expansion to reverse and the universe to collapse back into a single point, like the Big Bang in reverse. However, given the discovery of accelerating expansion, this is now considered unlikely. A more violent possibility is the Big Rip. In this scenario, dark energy grows stronger over time, eventually becoming so powerful that it tears everything apart first. Galaxies, then stars and planets, and finally, the very atoms that make up matter. Another fascinating idea is the Big Bounce, which suggests our universe might be part of an eternal cycle. It proposes that our universe emerged from the collapse of a previous one, creating an endless sequence of universes being born and dying. To understand our cosmic destiny, we also have to talk about dark matter. This invisible substance makes up about 27% of the cosmos and acts like a cosmic glue, holding galaxies together. Without dark matter, galaxies would fly apart. So, we have this cosmic battle playing out. Dark matter trying to hold things together, and dark energy trying to push them apart. Right now, dark energy is winning. Closer to home, our own Milky Way galaxy is on a collision course with our neighbor, the Andromeda galaxy. In about 4 billion years, they will merge, creating a new giant elliptical galaxy that some have nicknamed Milkomata. The night sky will look spectacular during this merger, but eventually, even this new galaxy will be subject to the universe's ultimate fate. The connection between space and time is key here. The physicist Freeman Dyson proposed a fascinating idea called eternal intelligence. He theorized that a sufficiently advanced civilization could survive forever in an ever-cooling universe by slowing down their thinking processes, entering long periods of hibernation between thoughts to conserve energy. As the universe cools, the time between thoughts would get longer and longer, but consciousness could, in theory, persist. So, where does that leave us? The mystery of what lies at the end of the universe is still one of the biggest questions in science. Current evidence points towards an infinite, flat universe destined for a big freeze. We are living in a truly remarkable era of cosmic history, a time when the universe is still filled with light, energy, and wonder. Humanity has billions of years to explore, learn, and maybe even find a way to survive the end. The universe likely doesn't have a traditional edge. The cosmic horizon is just the limit of what we can see, not where space ends. The cosmos is probably infinite, and it will keep expanding forever. But what do you think? Which theory about the universe's ultimate end, the Big Freeze, the Big Rip, or the Big Bounce do you find the most terrifying, and why? Let us know in the comments below. And do you forget to subscribe to the channel and hit the notification bell so you do miss our next journey to the edge of science. Thanks for watching.